Hello, welcome to another video for Year 9 Maths D. Today's topic is going to be on parallel and perpendicular lines. So over here, you just have to focus on this aspect that recall the equation of straight line here. And then we have to remember two things about this particular line. So parallel lines have the same gradient. And the next one is when you have perpendicular lines. When you have perpendicular lines, the product of their gradient is -1, right? So later you will focusing on how to form the equation of parallel and perpendicular lines. So these are the facts in your notes, right? Now let's start on the first example. Find the equation of a line parallel. So parallel to what equation over here? So parallel to this equation. And that line also must passes through this coordinate, right? Now, so let's have a look at the lines first. Now, let's say that this line is line 1, right? So the line that you are going to find is another line 2. So let's have a look here. So let's copy down this equation first. 2y equal 3x plus 4. Now you cannot really straight away assume that 3 is the gradient of this equation, because note that the equation of straight line must be in the form of y equal mx plus c. But here you don't see y, you're seeing 2y. So the first thing you have to do is to divide this equation by 2. And afterwards, cancel everything here. 2 divided by 2 equal 1. Y. And then this one, you have to split this. 3 out of 2. X plus 4 out of 2. So your equation for line number 1 is 3 out of 2x plus 2. Now you know that the fact from the previous one, you know that when two lines are parallel, the gradients are the same, right? So you take the gradient from the first line, which is 3 out of 2. So you are saying this. M1, which is the gradient for line number 1, and the gradient for the line number 2 must be equal to 3 out of 2. So you will have a m equal 3 out of 2. Now when you pass this through one line, remember from the previous equation, from the previous formula that you learned, you use this one, y minus y1 equal m bracket x minus x1, and you can get straight away the equation later. But let's substitute all the values that you know, which is y1 and then m and x1. So y minus what is the y coordinate? It's 2 equal m is 3 out of 2 bracket x minus the x coordinate of the line 2, which is 3. Right, so let's continue this one and then expand 3 out of 2 x. So I will just leave it 3 out of 2 x minus 3 out of 2 multiply with 3 will be 9 out of 2, right? So proceeding from here, let's make it into the form of equation y equal mx plus c. So we have to move -2 to the next one, to the right hand side, I mean. So y equal 3 out of 2 x minus 9 out of 2 plus 2. Now over here you have to simplify -9 out of 2 plus 2. So let's do a side working, which is -9 out of 2 plus 2 is actually 4 out of 2. Now -9 plus 4 will be -5 out of 2. So therefore your equation of the line is y equal 3 out of 2 x minus 5 out of 2. So that's for the first example, right? Okay, just have a look at the gradient first. This is line 1, 3 out of 2. The second one will be also the same, right? The gradient, I mean. So let's have a look at the next one. Now example number 2, find the gradient of the line perpendicular to y equal 3x plus 1. So now since this is already in the form of y equal mx plus c, so you can say that the gradient for this line, which is line number 1, and I will call it gradient number 1, m1 is 3, right? Now you remember from the fact over here that when the two lines are perpendicular to each other, m1 times m2 equal -1. So let's substitute to this formula. m1 times m2 equal -1. The first gradient is 3 times m2 equal -1. Now 3 times m2 is 3m2. You just divided this by 3, right? So your gradient number 2 will be -1 out of 3. So this is your answer because you have to find the gradient only. Right, let's proceed to the last example. Find the equation of line perpendicular to one passing through the coordinates 1, 3 and -2, -9. Now, when you form a line, the equation of a line, you need to have two things, of course, which is the gradient and the midpoint. Now, here you obtain the gradient and midpoint from given points first. So, let's say that this line, one passing through the coordinates of 3 and 2, 9. Okay, let's illustrate this. Okay, let's say that I have this one. Okay, this is over here is 1, 3, and over here is -2, -9. Now, this one is the L1, right? The one that you asked for is the line perpendicular to one passing this coordinate. So the second illustration for the second line will be perpendicular, actually perpendicular to it. So no, this is not L2, this is L1. So the second one will be L2, but over here, what is it? What is the point that passes through? From there, you can find the equation of perpendicular line which actually passes through the midpoint. So over here, this point that I will highlight is the one in the midpoint, in the middle. So this is the midpoint. So the first thing that I have to do is to find the gradient, m1. So m1 equal to your, according to this diagram, x1, y1 is over here, x2, y2 is over here on the bottom one. So m1 equal y2 is -9 minus y1 is 3 over x2 is -2 minus x1 is 1. So -9 minus 3 will be -12 over -3. Now simplify this, you will get m1 equal 4. Now that's for the first gradient. Now you remembered from the previous one, for perpendicular line, you have to use this equation, the formula. Now your m1 will be 4 times m2 equal -1. So divide this by 4, your second gradient will be -1 out of 4, right? So you are going to use this equation, right? Now, the one point that you have to find is the midpoint. So you have to use the same points over here to find the midpoint. So the midpoint, right? Midpoint will be x1 plus y1 will be 1 plus -2. So 1 minus 2 over 2. And the y coordinate will be 3 minus 9 out of 2. So -1 minus 2 will be -1 out of 2. And 3 minus 9 will be -6, right? Out of 2. So your midpoint will be -half. And then -6 divided by 2 will be -3. Now use this formula again. Y minus y1 equal to m bracket x minus x1, because you know your points, right? So y1 and then the m and then x1, you know them. So y minus your y1 will be the midpoint, so negative 3, equal to your gradient will be negative 1 quarter x, bracket x minus negative half, so this is negative half, right? Right, now y minus meets minus becomes plus, and then negative 1 quarter bracket x plus half. So you have to expand this, right? You have to expand this, and from here y plus 3 equal negative 1 quarter x, and then negative meets the positive, it becomes negative 1 out of 4 times 1 out of 2, you will have 1 out of 8. And then proceeding from here, your positive 3 becomes negative 3 on the left side, from the left side to the right hand side. So 1 quarter x minus 1 quarter minus 3. Now let's do side working. Negative 1 out of 8 minus 3. So when you have a denominator of 8, so 3 times 8 will be 24, right? 24 out of 8 is 3. Now negative 1 minus 24 will be negative 25 out of 8. So therefore your final equation will be 1 quarter x, negative 1 quarter x minus 25 out of 8. So that's it for the second equation. I hope that all the examples are quite simple and can be understandable. So don't forget to stick this in your notebook. That's it. Thank you very much and see you again.